Hello again. We are back with the quotient rule of exponents. This is another property of exponents. It says if I have two quantities with the same base raised to powers, we subtract those exponents. And the question is why? So again, we're going to take it back to an example, breaking it down to what do those exponents mean. So I have x to the 6th power being divided by, remember that's what a fraction bar is, divided by x squared. Well, x to the 6th is the same thing as x times itself 6 times. And then x squared is the same thing as x times itself twice. And anything divided by itself, so if I had 3 divided by 3, I'd get 1. Anything divided by itself is 1. So x divided by x is 1. X divided by x is 1. Now I have nothing in the denominator, and up in the numerator I have 1, 2, 3, 4 x's, so I end up with x to the 4th power. So how do we get from here to there? We subtract. I had 6 x's in the numerator, 2 in the denominator. 2 of them divided out. I take 2 away, I'm left with 4. Same thing with the as before with the coefficients. When we did the product rule, we multiplied the coefficients separately and then worked with the variables. Same thing here. I would divide out the coefficients, divide instead of multiply, and then subtract the exponents of the variables or the terms that have the exponents. So, first example here, I have 3 to the 6th divided by 3 squared. So a lot of times I see students try to divide out those 3's. But it's not just 1 3. It's not just 3 divided by 3. It is 6 3's divided by 2 3's. So only 2 of them divide out. And we end up with 3 to the 4th power. Or if you're asked to evaluate, 3 to the 4th would be 81. Most likely, if you had a problem like that on your homework or test or something, they'd want you to leave it in that form, just showing that you know that quotient rule that says if I'm dividing, I would subtract 6 minus 2 and get 4, so 3 to the 4th power. Okay, so again, this is a base here, not a coefficient. In part B, I have y to the 7th divided by y to the 4th. 7 minus 4 is 3, so I end up with y to the 3rd power. Below that, now we're involving coefficients. So don't subtract the coefficients. This is 16 times c to the 9th and 2 times c to the 4th. If I just had this piece here, 16 divided by 2, I would get 8. Okay, don't mix up the quotient rule with actual division of coefficients. So 16 divided by 2 is 8, and then c to the 9th divided by c to the 4th, I subtract 9 minus 4 and get c to the 5th. Now all the examples we've seen so far with this quotient rule, there have been more of the variable in the numerator than in the denominator. So I had 7 y's in the numerator and 4 in the denominator. Now what happens if I have more in the denominator? Well, 2 of them will still divide out, but the leftovers will end up in the denominator. So if I wanted to write this out, I'd have 3 squared in the numerator, and then 9 3's in the denominator. 1, 2, 3, 1, 2, 3, 1, 2, 3. So you did not have to write this all out. I just want to show you that 2 of these will divide out. And remember, it divides to 1. So now I have 1 in the numerator, and then 7 3's in the denominator. So 3 to the 7th power. You do not have to multiply that out. That's going to get quite large. I would just leave it as such. So if we have more of whatever we're dividing in the denominator, that's where it ends up. So I can still use the subtraction rule. 9 minus 2 would give me 7. So we see those 2 dividing out. But what's left over is wherever there's more. I have more in the denominator. That's where the 3 to the 7 stays. If I had more in the numerator, it stays in the numerator. Alright, let's look at this last one here. It says negative z to the 6th divided by z to the 11th. Don't be fooled by that negative. There's nothing fancy going on. It's just a negative number. So overall, this will end up being a negative fraction. A negative divided by a positive would end up negative. And then we can subtract. So 11 minus 6, I'm always going to do the big minus the small. 11 minus 6 gives me 5. And I had more z's in the denominator. So that's where those z to the 5th, or that z to the 5th ends up. And I put it over 1. So 6 will divide out. I would have nothing left on top, so it divides to 1. And those 5 left over are in the denominator. Go ahead and try the ones on the right-hand side. Okay, example A. A to the 12th divided by a cubed. We subtract, since this is division. 12 minus 3 is 9, so I end up with a to the 9th power. Next example, I have more b's in the denominator. So I'm still going to subtract. 9 minus 7 is 2, but those 2 end up in the denominator. So 1 over b squared. 7 of them would divide out, 2 would be left over. They stay in the denominator, since that's where there were more. Alright, next one. Now I have coefficients, so 6/8. It doesn't divide evenly, but if I just had the fraction 6/8, I could divide out a common factor of 2, and I would end up with 3/4. So I'm going to have a 3 in the numerator, 4 in the denominator. And then I look at my variables. Y to the 7th divided by y to the 6th. 7 minus 6 is 1, and I had more in the numerator, so that 1 ends up in the numerator. This would be the same thing as just saying 3/4 y. So if it's in the numerator, it's the same thing as just multiplying 3/4 times y. If that y was in the denominator, you would have to write it in the denominator. Okay? Next one. 15r squared times s to the 7th divided by 5 times r to the 6th times s. We're going to divide them all out individually. So coefficients first. 15 divided by 5 would be 3. That would be in the numerator. Then the r's. So r squared divided by r to the 6th. 6 minus 2 is 4. And that 4 ends up in the denominator, since there were more r's in the denominator. Lastly, s to the 7th divided by s. 7 minus 1 would be 6. So only one of those s's divides out, and they end up in the numerator, since there were more in the numerator. Last example here. Same idea. I have those coefficients of 12/18. It's not going to divide to a whole number, but I can divide out a common factor of 6. And I would end up with 2/3. So I'm going to have a 2 in the numerator and a 3 in the denominator. Then I go on to the a's. A squared divided by a to the 8th. 8 minus 2 is 6. I had more in the denominator, so those a's stay in the denominator. A to the 6th power. Moving on to the b's. B divided by b to the 4th. Only one b would divide out. 4 minus 1 would be 3, and those 3 would again be left over in the denominator since there were more b's in the denominator than the numerator. And there you have it.